In Calculus 2, all the chapters are very distinct and different from each other, and they don't have a lot of overlap. So that means that if you don't like what chapter you're doing, wait a while and it'll change to something completely different. And that is definitely the case right now. So we're going to spend some time in chapter 10, which means we're going to be working with sequences and series, in particular, infinite series. All right, so let's begin with just an overview of sequences and series. So before I even do that, I want to talk about the difference between discrete numbers and continuous numbers. So discrete numbers are quantitative variables that have either a finite or limited number of possible values or a countable number of possible values. Now, countable can be infinite, but it's countable. So you count it as, 0, 1, 2, 3, and so on. And you can keep going forever, but it's still countable because you're counting them. Discrete variables cannot take on every possible value. So in other words, between 1 and 2, I can't take on 1.1, 1.23, 1.1576. Like, those aren't possible. In general, if the variable is counted, it doesn't have decimal places. That's not strictly true. You can have decimals, but it has to be limited. But for our purposes, we'll just kind of say in general, no decimal places, and it's going to be discrete. How many, what number, etc. Continuous variables are a quantitative variable that has either an infinite number of possible values that are not countable. I don't know why I have the either. It's just they have an infinite number of possible values that are not countable. I think that was a copy paste error. Sorry about that. That means the continuous variables can take on every possible value between two limits. So in other words, it can be 1.576 or 2.32333475, right? It can do that, right? Whereas countable numbers cannot. Countable numbers have to be 0, 1, 2, 3, and so on. All right, so in general, continuous variables are measured and they'll have decimal places. And it's continuous, so like height, time, etc. Those are continuous variables. And speaking of which, this should have said discrete variable up there. Sorry about that. The integers and the natural numbers and the whole numbers and the ordinal numbers, all of these are discrete. So we're actually going to be working with discrete numbers. We've spent a lot of time so far in Calculus 2 working with continuous variables. So when you graph it, it forms a curve, if you will. But now we're going to shift gears into discrete numbers, which don't make curves. They make, well, dots, if you will. All right, so there are big gaps in there. All right, so the integers have a symbol of capital Z with an extra little bar in it. That's the symbol for integers. The natural numbers are a portion of the integers. It's 1, 2, 3, 4, and so on. And then whole numbers are technically natural numbers that include 0, but to be honest with you, a lot of times these are called the natural numbers as well by people. So suffice to say, they're close enough that we're going to treat them interchangeably. And then ordinal numbers are first, second, third, fourth. There's an order to them, as opposed to cardinal numbers, which are 1, 2, 3, 4, and so on. All right, so suppose you want to gather the following information from a patient. Determine which of the following variables are continuous or discrete. Okay, so when you go in and you say, my pain level's at 7, right? It's discrete. Now, that said, if you're feeling smart alecky, you could be like, my pain level is at pi, because that's a continuous number, and that would really annoy your nurse, which I don't know if that's the way you want to go with things, but you could. All right, so then the year born would be discrete, right? You're born in, 2000 or 2001 or 2002, etc. Your body temperature, on the other hand, is continuous. You can get more decimal places in body temperature if you just try. Age, well, age is a tricky one. Age is actually continuous. And think about it right now, as you sit and watch this, you're getting older and older. Oh wait, now you're older again, and you're older some more, right? It's going and going and going and going. However, when we round it to the nearest year, which we often do, that would be discrete. So you don't tell people, I'm 20 years and 5 months and 3 days and 4 minutes and 6 seconds. Like, nobody does that. Well, actually, they do that for babies. But when you become an adult, they don't bother anymore. But actually continuous. But when you round it, then you're making it discrete. Blood pressure, something you measure, that's continuous, right? That has a scale, so you can have decimal places and all sorts of stuff. Weight is the same way, right? You can have decimal places. Shoe size is interesting because shoe size in America goes 5, 5.5, 6, 6.5. And even though it has a halves, even though it has decimals, this is discrete, right? Because you can't have a shoe size that's 6.236. And remember, what makes it continuous is that it can take on every possible value between those limits. That is not the case. And that's why I said up here, in general, discrete variables have no decimal places, but it's not hard and fast, right? It could have decimal places as long as they're very limited, usually 0.5, which is what this is. This is 5.5, this is 6.5, but that's all you're going to get. So that's okay, that's discrete. Now, the amount of weight you've gained or lost, well, just like weight, that's continuous. So in chapter 10, we are leaving behind continuous things, and we're going to be working with these number systems to work with discrete things, because all of these are discrete. Even though they're infinite, discrete doesn't mean that it's finite. I mean, it can mean finite, right? So finite's possible, but also countable is possible. And countable can be infinite. These are countable number systems. Even though they're infinite, you count them. 1, 2, 3, 4, 5, 6, 7, 8, right? Even this one with the negative integers, it's still countable. So therefore they are discrete. Therefore they are what we will be working with in chapter 10 and chapter 11. As a matter of fact, chapter 11 will be breaching the gap between discrete and continuous. So we'll be back to hit on this idea again later.